it's a cubic. There's a minimum at the origin, well they tell us that there, a maximum here, and it cuts the y-axis at point A. Write down the coordinates of point A. So when they say write down, that's a clue saying it should be pretty easy. Now I know that doesn't help if you don't know what to do, but you shouldn't be looking for anything too complicated. And actually it comes from this equation here. So if we go up the side here, you can see that f of x is equal to x squared times 9 minus 2x. And we've got a repeated root here of 0, and that corresponds to the 0 here, and so this is the intercept we're interested in. 9 minus 2x equals 0, which means that 2x equals 9, and so that means that x is equal to 9 over 2, or 4.5 if you can't help yourselves. Now the coordinates of the point A are 9 over 2 along, 0 up. On separate diagrams, sketch the curve with equation, and there's two equations, so we're going to do that down here. So here's our first diagram. Now this is a translate, and it's in the x direction, and the vector would be minus 3, 0. Remember, inside the brackets it always does backwards, so it's going left 3. So my cubic curve is going to look like this. It's going to come down, it's going to go up, and then it's going to come down again. And it's really important that I write down all the coordinates. So to do that, I'm just going to have a quick look at the curve at the top, and you can see that we've got a 0 here, so that's been moved 3 along, so that is now minus 3 along, 0 up, because it's not been moved up or down. The maxima was 3 along, and it's been moved 3 this way, so now it's 0, 27. So then we'll put a cross on there. 0, 27. And this one, well, it was at 4.50, and now it's going to be at 1.5 along, 0 up. So make sure you get all your axes intercepts labelled. Now, a bit trickier, y equals f of 3x. So this is a stretch, and it's inside the brackets, so it's in the x direction, and it's a scale factor of 1/3, so it's actually a squish. So we're going to draw that over here. Now, there we go. So this point here is not going to move because it's on the axis. Everything else is going to get squished towards the axis, which means that the minima, instead of being 327, is now going to be 127. Notice the height hasn't changed, but the x coordinate has. And here, this was 4.5, and now it's a third of that, which is 1.5 along, 0 up. And of course, that's 0, 0. So there we go. There's our two sketches. And finally, the curve with equation y equals f of x plus k, where k is a constant, has a maximum point at 310. So let's go and have a look at that. So 310. So if we drew that on here, well, there's 327. So 310 is going to be somewhere down here. So it would look like this. And you can see it's been moved down by, well, it was, that's 310, wasn't it? It's moved down by 17. So what it means is we've got a translation of 17 down, so k is going to be minus 17. K equals minus 17. Okay, so that's our core 1 bit. Now we're going to go on to core 2. So we'll work on log equations. Let's do that one first. So remember we talked about spade. Can you remember what it stood for? I know the E was useless. With the subtraction rule, didn't we? with the power rule, with the adding rule, and the definition, didn't we? Okay, so subtraction, power, adding, and definition. So I can see here I've got the power rule, I've got a subtraction. So I'm going to start with the power rule, so that's going to transform this into log base 3 of x squared minus log base 3 of all the rest unchanged, x minus 2 equals 2. So that's the power law I've used there, or rule. And now I'm going to use the subtract, so that's going to combine both of these log base 3 statements into one, and it's going to be x squared on the top divided by x minus 2 on the bottom, and that equals 2. Don't lose your equal sign. Now, I've got a single log now, which means I can now use the definition. So what that means is that x squared over x minus 2 is equal to 3 to the power of 2. And this rearranges quite nicely into x squared is equal to 9 times x minus 2, which is of course 9x minus 18. So it totally finishes off to x squared minus 9x plus 18 equals 0. And notice at no point have I lost my equal sign. And now I'm going to factorise. So there's the x there and the x there. And it's minus 3 and minus 6. So x equals 3 or x equals 6. And there's 5 marks for the trouble. Question 3. Pardon me. So we're given a cubic, a polynomial there, and we're asked to use the factor theorem to show that x plus 2 is a factor of f of x. And very straightforward, all we have to do is do f of minus 2 and hope it's 0. Because if it's 0, then x plus 2 is a factor. So we're going to write out the substitutions. We've got 2 brackets minus 2 to the power of 3, minus 7 brackets minus 2 squared, minus 10 brackets minus 2 plus 24. And you type that into your calculator and you get 0. So we can say therefore x plus 2 is a factor. Now we're going to factorize this function completely, which means we're going to divide through by our factor and see what's left. So we've got x plus 2, and then we divide this cubic, 2x cubed minus 7x squared minus 10x plus 24. So x is into 2x cubed, go 2x squared, multiply it back through, 2x cubed, that's that times that, and now we do that times that, which gives us plus 4x squared. And now we do a subtract, so 7x, so obviously these two disappear, minus 7x squared minus 4x is minus 11x squared, and then we bring 10x down. Now x is into minus 11x squared, go minus 11x, and then we multiply it back over there to get to minus 11x squared and minus 22x. And we do a subtract here. Now minus 10 minus minus 22 gives you positive 12 plus 24. And if I had to pick somewhere you'd go wrong, it's going to be on these double minuses here. X is into there, go positive 12, and then you multiply it back through to get 12x, because 12 times x, and then we do 12 times 2, and that's good because we expected a remainder of 0, but this is the thing we wanted. So we have x plus 2, and then 2x squared minus 11x plus 12. And we've got some of these 4 marks already. Just to get all of them, we have to factorize the quadratic as well. So I'm just going to do that now, and that's going to be 2x there, and that's going to be x. I've got several choices for 12. We've got 1 and 12, 2 and 6, and 3 and 4. I'm going to take this into account, so 2 times 4 is 8, 9, 10, 11. That's supposed to be 11 there, isn't it? So it's x minus 4 and x minus 3. That's our solution. And obviously in the exam you would multiply it out and check that you'd got it right. Hope you enjoyed it. Keep working.